By now, you should be able to solve simultaneous equations. If not, please see my other video where I go over the elimination method and the substitution method. In this example, you need to know how to use the substitution method. Usually, you will have two linear equations where there are two straight lines and they are meeting and you're finding the 2 points at which they meet. In this example, you have some quadratic and a line going through it, and you're finding the 2 points that they meet at by finding the values of x and y. So the first thing that we're going to do is rearrange x so we can substitute it in to equation 1. If we add 2y to both sides, we're going to get x equals 7 plus 2y. So 2 would become x equals 7 plus 2y. Now let's sub this into this. So you're going to get y equals 7 plus 2y all squared plus 2, 7 plus 2y minus 3. As you can see, we've eliminated all the x's, so we can now rearrange and solve to find out what the value of y is. We expand this first, so you can get y equals 49 plus 14y plus 14y plus 4y squared. We then can expand this. We're going to get 14 plus 4y and then minus 3 at the end. We can now clean up. So let's look at everything where there is a number. So we've got 49 plus 14 minus 3, which is going to be 60. So you can get y equals 60. Let's get rid of those. Now let's look at all the y terms. We've got 14, 14 and 4, which is going to be plus 32y. But we only have one y squared term, so it's going to be 4y squared. Don't forget that there is a y here, so we need to subtract it from both sides. So then this would become 4y squared plus 31y plus 60, which equals 0. We can now solve this as a normal quadratic by factorising. So we take whatever the value is here and we multiply it by the value here, which is going to be 240. And you would find out what all the factors are to find which ones add up together to make this middle number. In this situation, it is 15 times 16, or minus 15 and minus 16. If we put an addition sign in between, this would be 31 and this would be minus 31. So this is the pair we're looking for. I have skipped a few steps for this one, but if you are unsure on how to solve quadratics by factorising, please see another one of my videos that covers it. So as we know it's 15 plus 16 equals 31, we can break this up. So that's then going to be represented as 4y squared plus 16y plus 15y plus 60 equals 0. Now let's just look at this. Let's pull 4y out. That means you're going to get y plus 4. You repeat it again. And we see what do we need to put on the outside so that it once multiplied in, it becomes 15y and 60. That's going to be 15. We now put whatever the y terms are twice, once, which is y plus 4, and we put everything outside the brackets in the second one. So we've now successfully factorised it. To now find out what the y terms are, we would make y plus 4 equal 0. So if we solve that, y would equal minus 4. And we make this all equal to 0. So 4y plus 15 equals 0. So therefore, y would equal minus 15 over 4. We now have two values for y. So to find out what the x terms are, we would take these values and now substitute it into either of these two equations. So let's do that. So I'm going to use equation 2 because it's a lot easier. So let's say when y equals minus 4, we have x minus 2y equals 7. So x minus 2 minus 4 would equal 7. this would be the same as x plus 8, which equals 7. Let's minus 8 from both sides, so you're going to get x equals minus 1. So we now know when x is minus 1, y is minus 4. This here is our first point. Let's now find out what the second one is. So we've got y equals minus 15 over 4. Let's plug that in. So we're going to get x minus 2 minus 15 over 4 equals 7. We can then simplify this by expanding the brackets here, multiplying it in. So you're going to get x plus 30 over 4, which equals 7. This is the same as 7.5. So this would be x plus 7.5, which equals 7. So therefore, if you subtract 7.5 from both sides, you're going to get x equals minus 0.5. So the second point is minus 0.5, and when y was minus 3.75. Minus 3.75 is just minus 15 divided by 4. So we've now found out what the 2 points are where they intersect. This is not what the graph is going to look like, but these are the 2 points that they're going to intercept with each other, and we've got them, and that's all you would need. And let's now put second point, and you should probably put a bunch of exclamation marks as well. Let's do another problem. Here we have something that looks a bit like a quadratic, however it's actually a representation of a circle. We're not going to go over that today because all we're really interested in is substituting it and finding the points at which they both intersect. But later on in your maths life, you may be able to figure out why that's a circle. For now, let's take equation 2 and substitute it into equation 1. We don't need to do any rearranging because it's already in the form of y equals 5x minus 13. So you're going to have x squared plus all squared 5x minus 13 squared, which equals 65. We can now expand these brackets. So you're going to get x squared plus 25x squared minus 65x minus 65x plus 169, which equals 65. Anyway, we can now clean up. So we've got an x squared here and an x squared here. So let's do 26x squared. Minus 65x minus 65 is minus 130x. And we have 169 minus 65, which is going to be plus 104. So that would equal 0. We can now solve this by factorising. You do 104 times 26, which is going to be, very obviously, 2,704. If you can't do that in your mind, be better. You would find out what all the factors are for this. However, that would take a very long time. So I know that 104 times 26 would equal that, or minus 26 and minus 104 would equal that. So if we now add these together, we would get 130 or minus 130. So we know that this is the pair that we're looking for. If this confuses you, or this method in the way in which I factorise confuses you, then see my other video on how to factorise a quadratic by using this method. So minus 26 minus 104 equals minus 130. So we can do that. 26x squared, and we would then put minus 26x minus 104x plus 104 equals 0. We can now just look at these two parts and we will factorize them. So 26x and what goes inside the brackets will be x minus 1, because when they get multiplied in, they're obviously going to make that. We repeat x minus 1. What needs to go on the outside for it to be minus 104 and plus 104 would be minus 104 on the outside. We take everything that's inside the brackets and we place it here once. We take everything outside the brackets and we place it here once. We have now factorized this. So now, to find out what x is, we would make this equal 0 and we make this equal 0. So if we have x minus 1 equals 0, therefore x equals 1. And then 26x minus 104 equals 0. That means x would be 104 divided by 26, which is obviously 4. So we've got the values for x equals 1 and x equals 4. We would now just take these values and substitute them into any one of these two equations. Putting them into this equation would frankly be stupid. So let's put them into this one. When x equals 1, y would equal 5, 1 minus 13. 5 minus 13 is going to be minus 8. So therefore, where your coordinate, your point, is going to be 1 and minus 8. So now I'll write here when x equals 1. So what about when x equals 4? We will now put it back into this equation. So we're going to get y equals 5, 4 minus 13. 5 times 4 is 20. So you're going to get 20 minus 13, which equals 7. So now we have 4 as our x term and 7 as our other. We've now found both sets of coordinates where this, it would look something like some sort of circle, and there would be some sort of line going through it. So like it would be 4 and 7, let's say here, and 1 and minus 8, let's say it's here, and it would be a line that would go like that. So those are the 2 points. Obviously this is an incorrect circle, however, you get the point.